Welcome to our tech session for the day. We have Jay talking us through some of the generative AI models, particularly practical use cases, ecosystem AI integration across the generative landscape. Jay is going to be taking us through a bit of a presentation and a live demo. Please feel free to add notes or questions into the chat, and otherwise speak up during the chat as well if you've got anything to say or ask about. In that light, as usual, we are recording, and these sessions will be on our YouTube page. If you are interested in what we've been talking about from a tech perspective, there is a lot of great stuff on our YouTube page at the moment. Madison will drop a link to our YouTube in the chat now. And other than that, Jay, if you could kick it off.
Yes, let's get started. So we have discussed agents and the concepts behind some of these things before, so I'm going to just go through this very, very quickly. Our contribution to the agentic world is essentially seen as a parallel capability rather than as an horizontal integration the way that you would have with the primary platform providers. So we compete with OpenAI, we don't compete with Google. We are essentially a specialized enterprise style of agentic framework that comes with an element where you can deal with approximations and accurate predictions that are quite specific to the scenarios that you want to implement. What we have done is create packaged solutions, and not something that you're just going to get out of the box in its entirety and deploy it. You can bring your own data, bring your own algorithms, change parameters, and get them to work. The idea is that we're going to talk about what's called intelligent sales, and the journey that I'll use as an example is something that we know is close to many companies' hearts. That is to figure out an intelligent way to have a conversation with a customer to a point where they purchase something where you can integrate all of the various algorithms into that journey, depending on the decisioning that you want to do. So this module comes with a number of predefined assets. And as I go into the workbench, I will show you what those assets are. For today's purposes, I'm not going to get into the recommenders themselves or the nudging technology. I will just reference those and show you where those are integrated into the overall journey so you can create an end-to-end perspective of what it is that you're trying to achieve. Normally, what will happen is if you think about these modules, maybe just a quick kind of the way that the concept would work. If you use any of the online tooling or SaaS tools, you can configure a lot of those capabilities yourself and then export it to take it into a different environment. Because we are not a SaaS platform, we are a prediction as a service platform, means that you could run the entire architecture in your own environment. You can run it on your desktop. And for those that are interested, I'll point you to the site in a moment. You can download or get a Docker instance installed, apply for a key from us, and we will then issue you that key that you can then use to run any of these capabilities. If you want to try it online, you can just do it through our prediction as a service environment if you want to test the capabilities. I think looking through the fact injection concept, and fact injection is the ability to bring recommenders and other capabilities into your journey to make sure that it can execute properly. So we have got custom GPTs. If you go to OpenAI's custom GPTs, you've got all of them that you can use, including some technical ones. Online, if you go to Azure or AWS cloud environments, you can go and spin up instances. We've got online developer sites with a lot of documentation. We can look at what's available there, and the ultimate scenarios that you just talk to us directly, or we connect to our Slack channel publicly, and we can have a number of these conversations. On the developer side, it's developer.ecosystem.ai. Docker Hub, you just search for ecosystem AI as one word. You'll see that on Docker Hub, we've got about 30 or so different containers being maintained that you can install and run if you want to. We also have public repos. So on GitHub, you can get some open source repos that are related to algorithms and utility libraries for Angular and for React. For Python, there's a Java environment for the runtime. There are also an Android and an Apple app that you can get the source code for, depending on how you want to connect with our product, and it's already configured. And I'll demo one of those in a moment, just so you can see what they're like. We also have some what we call intelligence GPTs, like the recommender systems is a great one because it's got our recommender capability and everything in the background, including about 100 different recommender algorithms pre-prepared. So if you wanted to get some advice as to how to implement whatever the variation is of recommender technically, this GPT is pretty good at explaining how to do that. You can also look on our website under GPTs and you can get a lot of access there. So that's just a little bit of background so you've got some understanding of the broader spectrum of the ecosystem. Let's spend another 2 minutes on the concept of LLM. And what I want to switch out into some demonstration examples. Maybe we go between the presentation and what happens in the at a core concept. When you deal with a GPT, that is a generative pre-trained transformer, there are pre-training that's being done that normally will take into account a certain data set or data sets. That data set goes through preparation. It is trained through an encoding process. It is then used for text completion. And depending on the examples that you use, you can apply it in story, summarization, categorization. And there's a direct relationship between the model type you're using and the kind of response you're going to get. I will show you that in a moment because they vary depending on how they are applied. The transformer architecture is where you take text, and that text is taken through an encoding process. It's then encoded, and when you want to then do inference, and that means you want to decode that particular text, you can then go and ask anything about the pattern that was recognized in the context of the data training. Today, I want to show you how it works. You don't really have to worry about this too much because by the time you get to deal with how tokens are generated and recognized, you just want to know that the model you are applying in the context of the job that needs to be done in agentic is done in a way that is going to be reliably consistent. That is what the biggest challenges context of any generative tool rather than a discriminative-based AI solution where you know that it's explainable and it's pretty much usable in a very reliable way. So the challenge with this is that what is the approach and how can I extract something like intent? And that's the core of a lot of what happens inside the agentic world. So why don't I start with that as one of the examples that we can maybe use as a basis to start from. So what I'll do is pick a model. It's going to pick a model called Tiny Llama. And Tiny Llama is a model that has got a 1.1 billion parameter model, incredibly quick. Let's say I want to use it and we're going to use something that is kind of like a slang style of saying hello. So I'm going to say, hey, dude. And we see what kind of response we get from it. Now, if you look at the performance of this kind of model running on fairly slim infrastructure, it is incredibly quick, as you noticed. And then look at how verbose even this 1.1 billion parameter is. So by this saying, hey, dude, I said, sure, I'd be happy to with some examples of AI and so on. So immediately, it really gives you a result that is maybe questionable. Why would it not just respond to you? Let's take now an example like Llama, and Llama 3.18 billion parameters, so that's a slightly bigger one. When you ask it the same kind of question, what you're going to see, it will say, what's up? What do you want to chat about? You can see immediately a single prompt or a single piece of input text that gets completed through how the transformer was prepared with its chat layer gives you a different result. If you use something like the GPT open source model, the 20 billion parameter model, that's a nice model to use, especially for agent recognition. It is costly because it uses a thinking process. So that means it will take a little bit of time and you'll see that it thought for a second, we need to respond conversationally and friendly. And it did the thinking and it said, hey there, how's it going? The conversational differences are quite distinct. Now, if you want to apply something that you would normally use in the context of any agentic journey, and you want to figure out how a model is going to respond if you say to it that I'm going to give you a task to classify the user's message. Let's make it quite specific. Let's give it an array and say that it either is something that is about accuracy related activity or a knowledge extraction. Do a classification problem where I figure out if something is accurate or general. Now, the reason why this is needed is that this is how you implement guardrails and rules and how you get agents to decide which route they're going to take. And I'll show you in a moment what it looks like in OpenAI and in the ecosystem environment and in two places. So immediately it came back and it said, if I just say, classify the users, sorry, start that again. I didn't give it any text. Let's give it a task, and I'm then going to say that user message is, hey dude, let's do that same what we did earlier. You see it goes still back to the thinking, and it comes back to general. If I then ask it, what is my bank balance, you'll see that it will, now I have to decide if I'm wanting another that is accurate or if I want it to be general. You see that it still thinks that it's general. I say that my balance is $9.99. It should now respond with saying that this is about accuracy. And now we're going to see how the different models respond. Once we get one of them to work, you're going to see that the other models might not end up working in the same way. So let's look at the reason that it has to go through, the amount of work it has to do to solve that very simple problem. So we have a classification task. We have to go through this. Given the amount, my balance is 99, could either be a statement where they possibly, the system verifies the balance, they don't ask a question, and they come back and eventually it said it is still general. Okay, so now it means that I'm sitting with a challenge that if this model gives me general, and let's just take this exact example. Let's change this model back to our tiny llama. It's quite an efficient model, but efficiency comes with, and it comes back according to the message you classify, according to the information the user's balance is not accurate. So that means it came back and it said accuracy. So that means it might be able to do this fairly reliably and quickly, where the OpenAI model went through at least looks like 200-300 tokens of reasoning and still just gave the answer of general. If I now pick a different one, let's take Phi 3. All right, now Phi 3 is Microsoft's model. The Phi 3 Mini is a pretty efficient model, and it came back category of accuracy, but you see that it's still giving you a number of tokens. So it's very difficult for an agentic flow to decide and take an action on the back of this kind of response. So you need to then add it to say to it that the result provide one word only as category, right? So that means that you have to, and it then gives you the one word. So that means models sometimes can be verbose. And if you can't get it to reliably provide you with results, you're going to keep on getting problems by the time you run your agentic journey. If we now go back to the OpenAI's model, it now goes through thinking and it decides what to do, and you might run the same request to a model, and this time it says accuracy, where in the previous examples we did earlier, it said general. So that means that the model can be highly unreliable depending on how complete your response is and what size of model you are willing to use. So if you look at something like Mistral, that is a model that we have found to be pretty good at answering these kind of questions, they can be quite useful in any agentic journey, even though it now gave me general. If I try it again, and let's see how many times we have to try it before it decides that it is something that is still general. Okay, balance is, let's make that exactly $9.99, still general. So that means that every model will give you a different answer. Okay, everybody okay with the construct? So that means that detecting the intent is a very, very deep problematical problem. And this that I'm showing you to do reliable prompt injection is one of the most important prompts that you will create in any agentic journey, because that is what's going to get your model, by the time you execute it on the ground, to perform well, because you want it to be able to execute on what those various categories are that are being spoken about. So if we go back to our presentation, you'll see then that this text completion through the decoders producing these output layers and every token is generated means that you probably want to go do reading on the model card or the systems card of the model that you want to apply. And the systems card will show you the model specification, the way it was trained, and all of its characteristics. And every model will have a different prompt environment. So you need a prompt library, and you need a capability where you will add a specific prompt in a specific style to a model type to make sure that it's going to give you the right kind of result. And that is probably why companies who implement it on, let's say, public tooling like OpenAI's public environment where it's accessible for the whole world to see, you can use their model because they already have a fine-tuned version of categorization. But as soon as you implement your own company, you want to do it at scale, and you want to use various models to get your cost, especially if you're going to generate millions of tokens through an execution process, you want to make sure that you do that correctly. That means you need to have some understanding as to how the model gets trained. So that means when you build a model, the preparation and the sampling and the data that was used, you probably don't have line of sight of it. You probably don't have line of sight of the training loops, of the epochs that we used, of how the encoding worked. All you have some kind of understanding of is how the model behaves in the context of its classifier at the end of that journey. So you only really have an understanding as to what it happens in. And that's why you probably need to set up a test environment where you can take the most appropriate model. Or normally when we deploy a agentic environment, we will configure it with a particular setup that creates a test case for it to work within that scenario. And the agentic workflow will contain, if you start at the bottom, it shows a human input, a chat, or an initiation that happens from a piece of technology or an interface. It will then go through some kind of checking what memory and reasoning it needs to do to figure out what to do, and that reasoning can sit within a journey. So that journey that you configure, let's just go back to our world, and we look at one of our journeys. If we take a journey that has been configured, it could end up looking something like this. This is what it looks like in the system environment. And every single node has a number of properties defined to ensure that your guardrails and everything are correct. So you can define all of the various definitions and execution paths to get a model to perform in the correct way, right? So that means that you need to have an understanding of all of these elements. That's what the fact injection engine does for you. This journey here is a full sales journey that somebody can take in the context of whatever a device is. Let me show you that. I'm going to reset this user, make sure it is pushed, and share on a device so you can see what it looks like. This is an ecosystem app. And in this app, I'm telling it to go to the ecoagentic journey instead of OpenAI or any one of the other tools. And I'm telling it to use what's called ecoagentic 1.0. So that is an ecoagentic journey. It's tell this backend what work it needs to do. If I just go and I say to it, because the model is now set up to execute the journey, there's a default setting at the backend that picks up the fact that my user has been pre-configured, my token has been assigned. If I wanted to identify myself, I can sign in here in the server connection, and it will then use my own personal credentials. So you can have your security and everything when a person signs in to perform an action. So let's say that you now have been identified and you are John, and it will then, in this journey from telco company, how can I assist you today? Data, bundles, or devices or internet service. Say, well, I want a new device. Think about what the intent detection engine needs to do. To take this sentence and extract the intent of this conversation to make sure that it guides you to the correct place. So the back end, in context of the journey, will go and figure out what to do, execute the appropriate services, run the recommenders, and something that is an approximation of what is correct in the context of who you are, with your eligibilities and the rules related to you as a person. And in this example, the new specials on devices that are available to you are these. Not the generative model that created the list of devices. It is a recommender that is trained and prepared, or it's a dynamic recommender that converge based on your actual properties in your business that does this. And I think, in our previous week's session, Ramsey did take people through how that works, and you kind of get a feel for that. So now let's say I pick one of these, and you see that it will force me to use a singular nature. So you can kind of think of it like an expansive conversation, intent detection, guardrails, because I might ask about the weather and they need to bring me back to the point where it presents a few options to me, and then I select the option that opened up my conversation and it closed it so that I couldn't say, yeah, or make this 10% cheaper, or hack the system, be able to not allow people to hack the journey. Now it shows me when I say, for this example, no, I'll come back and say, do you want to go back to the product list? I'll say yes, because it can now pick up the fact that I'm saying yes, no, through the intent detection, and goes back to the singular choice. Let's now say the options are 1, 2, 3. Now say weather. Let's give it something that is completely non-relevant to this example. Sorry, none of these things have been your liking. Do you have any other questions? It immediately threw me out of the journey, so that the guy will now say, well, okay, I want the device. Let's go back to the conversation. And the idea is that it will then go back to the recommender, call it again, you'll get your result. You pick, let's say, an item that you like. Once you selected the item, returns it with whatever the results are that you get. And I say, yes, I want to purchase this item. And now, because in something like a telecommunications journey, or some cases in banking, or many industries, you straddle categories. You don't keep on recommending in the same category if the person is already taken up an item. So there's no point now going back. You could ask for another device. In this case, I'm going to say, yes, I want some data. Come on. Want some data. So the idea is that let's see if it detects that I'm wanting a data bundle, and it needs to take me down a different category. And I say, okay, fine, these are the data bundles available to you. You can have a 1 or a 2, and it forces me again to select the item. Any of these are interesting to you? Sorry, there, let's go. Do you want to purchase this product? Let's say I take those 2 items. Thank you. Do you have any other questions, or do you want to check out? I want to check out. And my journey ends there. It will then restart the journey. It'll say, fine, I can transfer you, or I can conclude the deal, depending on if I pass you to the payment. You've been transferred to a representative to finalize your order, and that means that you can build up your shopping cart, your conversation, and the intelligence of what needs to be accurate comes from the data that I have about you. The approximations that figure out what I recommend to you at what point and where uses an algorithmic-based and an explainability-based approach to figure out what is most relevant to you. Because as a company, a generative model is not going to know what I sell, how I sell it, how I price it, what is relevant to me as a person. It doesn't know me as an individual. The model is data around how many times I've topped up, what device I already have, if I'm a contract or prepaid, and there might be thousands of variables are used in eligibility. It might see that I'm likely to churn and offer me a free data bundle, or it wants to offer me a new device and an upsell. All of that gets done in the context of the recommender. Then it gets morphed into the agentic journey that then essentially is the journey of the conversation plus the agents that need to do all the work to get to a point where you can see something you can purchase. If you wanted the journey to then have human in the loop, it break out at this point. So at this point, it could break out through a phone call or a WhatsApp chat. It's nice for us to show it in our own app environment. Now, I think you're going to get a feel, all right? That just means that you have options around how this can be configured. If you wanted to see how this works inside the ecosystem workbench, you don't have the same visual capabilities, but let's show what it looks like when you run it in here. Let's close that up on the side and make this a bit smaller. And let's go just reset this user. And let's say I'll start a conversation and I want to see how the journey executes through its various steps. If I go high, you immediately will see that it brought that back, and you see this block here is highlighted. Okay, so that means it started with the properties node. It was the beginning. It went to the condition node. It figured out that I have been identified because there is a user identified there. So I've logged in and I'm the right user. It then gave me a message to say that, hello, whoever you are, this is the company. What can I do for you? That means that you could either do this through a pure generative conversational agent, or in this example, you don't want the model to go and generate some kind of message that is not approved by you because you might be regulated, you might guide it to the right place. In this case, it will skip the feedback loop. If we now look at how it's configured, you'll see that in here, there tells you what the conversation is about. You see we haven't got any guardrails set up. We haven't got any routes set up, but it then passes it. If we now look at the conversation, it's going to go through that central node. I want a new device. Okay. Now the execution is going to do the intent detection in the back end. Once it detected the intent, guide it through to the next agent, and you'll see that here it got to this node here. That node called a recommender. A recommender is a configuration in the telco sales for devices. It's got a catalog of all of your devices or what you tell. It works out using an algorithm. There's a client example from the website, and it uses whatever it needs to get that scoring done. It sits inside a recommender infrastructure, and it gave the result back to say that the new specials are, it doesn't loop everything. It only shows the top 3, or you can decide what number you want to display. And then you have, in this case, you see there's a recommender for recommender injection. And in this case, there's also the chat forcing you to pick a number, 1, 2, or 3. And that then gets you down a route. So you can navigate it. And ideally, if you had that could have been a button or something else that you can select to make the user experience seamless, even while the person is having some kind of free conversation. So that just means that we set up journeys. And let's look at the node configurations behind the scenes. You'll see that there are a whole different node types, and the node types, they've got an execution capability that each one comes with a different kind of setup that you can just maintain here. There are also different recommenders. So there's an internet offer kind of recommender. There's a special device offers, data bundle recommenders, and our agentic capability have got all of these already pre-integrated so that you can run it inside your company safely integrating, and then you can bolt on the chat interface that can sit facing the outside of what you are doing to the rest of the world. Okay, so now let's say you want to turn this entire agentic configuration, this entire journey into a single agent. Let's say that you want to wrap all of this and you then want to expose it through Model Context Protocol for this to be integrated in a public chat. Let's say you want to integrate this into Anthropic's Claude, or you want to integrate it with OpenAI. You can then do that too, or you can integrate it with Microsoft's Copilot or whatever the technologies you want to use in the backend. So let's take 1 or 2 examples of that. The MCP itself means that there are different on mcp.ecosystem.ai, and then you'll see there's a thing called processor runtime. You can go and execute a recommender or do whatever it is. Normally, this MCP environment will sit behind your firewall inside your enterprise with all of the security and the data configuration pre-approved. And it will also then have a thing called process eco. You can have a chat in a chat agent so that the chat agent in the backend sits within your secure environment without having to have it public. That often happens with these agentic tools that can create all kinds of challenges. Let's take that example for a second. To read the agent, and let's do a topic first. If you go to Claude, inside Claude, we've already configured the agent. So that means the MCP agent connects to that backend. If I go look at runtime offers, it's got turned on the runtime ping, processor runtime, process ecogentic message. You can enable the message directly within Anthropic. If this customer is not identified, you can use Anthropic login to connect to your backend that has got the private agent doing its work. Where in this example here, I just said the runtime ecogentic, I want a new device, and there was a journey earlier to show the concept. But basically, you can interact with your private agent that in its own right is a full journey. So you don't ever have to expose anything that you do in your private organization to the outside world other than that single interface that you allowed to go outside. If you do this, and let's say you want to do it, and you know that OpenAI launched yesterday their new agent work. So we created a couple of demos just to show you. So there are a couple that are publicly available if you wanted to connect them to your agent environment. An example of what it looks like inside OpenAI. So in OpenAI's agent builder, in this case, it just checks guardrail on the front end of a conversation to stop the person from dealing with anything that's profanity or anything of the sort, or racial slur or anything, that you can stop all of that kind of conversation. And then you can either, if it fails, and you can kick off an entirely different message, or if it succeeds, it then calls the runtime MCP that is the entire agentic journey in the backend configured, right? So if I go look at this MCP, you'll see that all the tools that are available through the mcp.ecosystem.ai can then be registered and used for whatever journey you create yourself. So you can bolt in any of our journeys that are secure into a public environment. Like in this case, process ecogentic message is the one that is configured. If I want to just test this to quickly show how that works, and I'll start with that same kind of conversation like the hi, you can see it's also got that journey execution. That's what you should expect from your agentic company anyway that you work. You should have a kind of a journey configuration environment where you can set up whatever that journey is. We support way more sub-modules and recommenders pre-built for you rather than having to do a lot of that yourself. So in this case, you can see here that I checked that the text is safe and it said hi. It then went and it set up the process ecogentic message to MCP server because it's already pre-defined in the Connex standard. It then executed the hi. It is busy thinking about it. Do you have any questions? Remember, we were busy with our chat on the previous device. If I say to it, well, show me some devices again, what it's doing, the guardrail gets checked again. It converts it into an ecogentic journey. The ecogentic journey then executes the journey in the back end to make sure that nothing goes astray. It goes and checks your balances, checks your values, gets your recommendation values, bring back the result. It's passing, well, almost there. It's executing it now to get the result. In this response, I'll show you in a second what it looks like. You can then see the payloads that came back from the scoring engine and from that particular journey. Here you can see those devices. You could bolt in any of the ecosystem-related configurations using our capability, bolt it into an MCP that fits into public or other tooling that exists out there. And you can configure that in a way that will make it deployable for you. You can also have environments where you have a knowledge base. So this example, it configures an if then else, and then it goes and check, and it calls our MCP server again, and it then uses in our MCP server a special type of configuration. And this configuration is a dynamic calling of the backend called process runtime. This process runtime configuration takes a runtime server, a server that needs to connect to, and a payload. If you look at how the agent is configured, all you have to do is give it a task and make sure that the task extract the customer number and add, in this case, I'm pointing it to the bank runtime invocation. So that means it's a engine that is currently running in the backend infrastructure, and the agent will then route it to the right place to go get the scores done. Okay, so that just means that you have a multitude of different options that you can use to integrate the ecosystem journeys into any public journeys currently available. Okay. So if you use Microsoft Copilot Studio, you can do the same kind of configuration. You can call a backend. Come on. Should refresh. Why is it not? You can then go call a backend, and you can then go and see how that backend calls runtime engine that will then get the result back. In this case, it passes the key and everything to the backend, and it brings back the results. You can have the same kind of environment with that same journey that you've configured deployed through Copilot. So you can decide Anthropic or Copilot or OpenAI, and it's kind of completely platform independent in the context of these public chat environments. If you want to use our app, your own app, or you want to use open source chat app, and let's go back to the one that I showed earlier. Let's take this entire conversation into the ecogentic mode. So let's just talk to, firstly, what fact injection is. Okay, fact injection basically is the concept where you can set a mode of operation, and in that mode, it can do work for you. In this case, I'm just going to say to the model, give me some help, tell me what I can do. And I want to look at the configs that have been prepared. In case it shows me these configs. Those configs in the ecosystem environment have been configured to be doing some work for you, depending on where that is connecting, right? And then you then have different types here for data that's private, or can do various kinds of fact injection capabilities, right? So in this case, let's take an example just to see how this works. So I set no context, and I ask it how many transactions for customer 590. If you ask a question like that to a generic model, I've not any context, it should come back and say, well, what do you mean? There's select that. It's going to tell you how to do it. That's what you want. You want the intent detection engine that is pre-prepared with all of its capabilities, and you want the work to be done by the agent and bring back a result. And now what we're going to do is set the context. Let's use this bank customer context. Now you see configuration set as bank customer. If I now go and ask it that same question, that the context has now been altered, it comes back and it says customer 590 has 2,663 transactions. That means that you can immediately, so what you need in your agentic journey is a reliable intent detector. Based on that context, you can then let it do whatever works. So let's say that I want to ask it something about define spend personality. Like an example, you spend, it switches my context, and I ask it define. It does in the backend for the first time when it calls this. It indexes the data set, it goes into the vector store, does the cosine similarities, work out with the prompt of what the response needs to be, and it'll come back and give me a specific definition where this definition comes from a knowledge base, but it's not a generic definition. That means as you set the context through your journey, it will find the exact route relevant to the things you want to do in that particular moment, whatever it is you're busy working on. When you then put it all together, like that journey that I showed earlier, in this journey, there are a number of places where intent is set. So if we look at, I wonder if we got it in the description. Let's just check quickly. Please provide your account. No, I don't think we got it set up. Which one was it, Ramsey? Maybe let's quickly
just look under roots.
So under roots, oh, there we go. Okay. So what the root does, it sets up the different roots, but it doesn't base the context. Basically what it does, oh, there we go. Use intelligent sales telco info. You see that use command there in the back end, set the context for you. So that conversation in that particular part of the journey is then narrowed to make sure that it only performs that work, so that you don't have to go and code new tooling or anything like that. You can literally just configure that journey to do that kind of work for you. Okay, let's just get back to, if you run like this, runs on the chatbot.ecosystem.ai, but it could have been, in your own environment. When you install ecosystem, we normally, the way we install and we get all that configured for you, or you can run a public version of this yourself. And I'll go to that. Remember, I've been in that journey earlier. So let's go reset that journey. It's going to reset the conversation. Go back here. I'll start with a hi. Now what will happen is the backend, hello, John. Means you can from any angle, any app, Python code that you use, whatever it is, to access the backend, and it will then be able to give you that response. I want a new device, and it will then be able to execute whatever that happens. Doesn't matter what the front end chat environment is that you're using. Okay, so at this point you have a certain model type that then allows you to do the work in the backend. So you can turn the entire journey into a way that you can then deploy it in whatever environment you want through a module, and that module makes it then accessible for almost anybody. So I think that maybe for today, Jess, Nicola, this might have been too much detail, but I think this is a good entry-level view of how the various technologies and all of the pieces fit together to show the journeys and how they work. Yeah.
Yes, definitely. That was actually perfect. I mean, that was very much what we were looking for. We had a couple of people join a little bit later and a lot of people joining as the session was going on. I don't know if anybody has any questions, because there's a couple of people online that weren't here when we started. That questions are more than welcome. So if anybody has any questions or thoughts, now would be a great time to chat. We've got about 10 minutes to discuss.
I think that if anybody wants to try it out or contact us to deploy any of this themselves, they'll be able to apply it on a website or email Amy, and then we can help you with getting your journeys configured. Because the options are quite broad. Maybe to go back one step from what we discussed before is that, we support the static model capabilities. So that means model trained on data and the ability to view the performance of those over time. We have the dynamic models that support a multitude of different algorithms like Q-learning, Bayesian probabilistic, human behavioral algorithms, and network graphs, and so on. All are different classes of problems that we are looking at solving. Within the human behavioral algorithms, we got loss aversion, risk prospect theories, and we also have anti-recommenders, the things that are so popular that you don't want to appear together naturally. Weighted regularized matrix factorization is like an anti-recommender or an unpopular tail that you want to find out what those are. Or you can also, if you want to, eventually you can use generative models, and the generative model capability, you can prompt with various inputs. We call places like Grok to do high speed. If you don't want to use any of these algorithms, create your own prompt. And we have got a prompt generator that sits inside our generative space. The prompt library will see contain a whole lot of different kind of prompts. Some of these are quite simplistic, but you can fill your prompts with the results, validate them, see which ones work best for you, and then apply them to the scenario that's best for the application that you use it in. Yeah. Okay.
All right, amazing. Guys, thank you all so much.